Hello class and welcome to our third lesson for atomic concepts. This lesson will deal with isotopes, and our major understanding for today is that atoms of an element that contain the same number of protons but different number of neutrons are called isotopes, and the average atomic mass of an element is the weighted average of the masses of its naturally occurring isotopes. Okay, so isotopes, atoms of the same element contain the same number of protons. So if we look at carbon 12 and compare it to carbon 13, since they're both carbon, they're both going to have 6 protons in the nucleus. And because they're electrically neutral, they're going to have 6 electrons in the outside orbitals. So both carbon 12 and carbon 13 both have 6 protons. It's possible, however, for two atoms of the same element to contain two different numbers of neutrons. Okay, and so for carbon 12, since it has a mass number of 12, it has 6 neutrons and 6 protons. But carbon 13 has 1 extra neutron. Since it has a mass number of 13, it has 7 neutrons and 6 protons. So atoms of the same element with different numbers of neutrons and hence different mass numbers are called isotopes. Since isotopes have the same number of protons, they share the same atomic number and element identity. The difference in numbers of neutrons, however, changes the mass number of the element. So if we were looking at lithium 6 and lithium 7, both of them have the exact same atomic number of protons, and as a result, they're both lithium. So they both have the elemental symbol Li representing lithium. Where they differ, however, is in their number of neutrons, and so they have different mass numbers. So the mass number of lithium 6 is 6 because it has 3 protons and 3 neutrons, and the mass number of lithium 7 is 7 because it has 4 neutrons and 3 protons. And again, when we're dealing with mass numbers, we just ignore the electrons because their mass is so small, it doesn't really contribute at all to the entire mass of the atom. Since multiple isotopes exist for elements, we have to figure out their average mass or average atomic mass. So using hydrogen as an example, we have 3 naturally occurring isotopes of hydrogen. Hydrogen 1, which contains 1 proton, so it has an atomic number of 1 and a mass number of 1. Hydrogen 2, which has an atomic number of 1 and a mass number of 2 because it has 1 neutron. And hydrogen 3 with an atomic number of 1 and a mass number of 3 because it contains 2 neutrons and 1 proton. So not all isotopes occur in the same percentage in nature. Looking at the percentages below each isotope, you'll see that hydrogen 1 occurs naturally more than either of the other 2 isotopes. And so some isotopes are more common than others. And so when we take the average, we have to take that into account. So the average atomic mass of an element is the weighted average of all the masses of the naturally occurring isotopes of that element. So since 99.985% of all atoms of hydrogen are hydrogen 1, when we take the average, we have to take that into account. And so what we do is we take the mass of each isotope. So hydrogen 3 has a mass of 3. And we multiply it by its percent abundance. And then we add that value to the mass of each isotope multiplied by its percent abundance. And then since this is out of 100, we then have to divide by 100. And we'll find that the average atomic mass is 1.000794 atomic mass units, or 1.00794 U. And looking on the periodic table, we'll find that this number appears in the top left-hand corner of the box that contains the elemental symbol hydrogen. So an atomic number of 1, because all hydrogen isotopes contain 1 proton, and an average atomic mass of 1.000794. And the reason why this number is so close to 1 is due to the high percentage of hydrogen 1 existing in nature. The average atomic mass of an element when rounded to the nearest whole number generally equals the mass number of the isotope with the greatest percent abundance. So let's look at a different example to illustrate this point. Let's look at neon. So neon has 3 naturally occurring isotopes also. It has neon 20 with a mass of 20 atomic mass units and a natural abundance of 90.48%, which means if we took 100 neon atoms, 90 of them would be neon 20. The next isotope, neon 21, has a mass of 21 atomic mass units and occurs in nature 0.27% of the time. And neon 22 has a mass of 22 atomic mass units and appears in nature about 9 out of 100 times. So if we had 100 atoms, 9 of them would most likely be neon 22. And so using the same equation we used earlier, we take the mass of each isotope and multiply it by its natural abundance. So neon 20 has a mass of 20, and so we multiply it by 90.48%, which is its natural abundance. And then we add that value to the mass of each isotope multiplied by its natural abundance. So the mass number of isotope 21 has a mass of 21 and a percent of 0.27%. And isotope neon 22 has a mass of 22 atomic mass units and occurs 9.25% in nature. And then we divide this whole value by 100, and we'll get the average atomic mass of neon to be 20.1797. And again, the calculation for this isn't really necessary because this value is given to you in your periodic table of elements, again in the top left-hand corner. So neon has an atomic number of 10, because it has 10 protons, and it has an average atomic mass of 20.1797, which if we were to round this to the closest whole number, it would be 20, which would equal neon 20 as the isotope. So it's the most common isotope of neon has 10 protons and 10 neutrons. And we know that due to the fact that its average atomic mass, when rounded to the closest whole number, equals 20. And so that covers isotopes and average atomic mass. Practice this equation on your own, and I'll see you next class.